Okay, so we're about to start our study of trigonometry. Trigonometry is actually the study of angles. A lot of people think it has something to do with the study of triangles, but that is not true. It's all about the angles. Now, what you are familiar with already is something called right triangle trigonometry, which is probably where the misconception comes in. In terms of the right triangle, there's two different relationships that you already know. If you recall from a right triangle, we have the right angle here, usually denoted by a box in the corner, and then there are two acute angles. I'm going to call this one A, I'm going to call this one B. What I know about those two acute angles is that the measure of angle A plus the measure of angle B is going to always add up to 90 degrees. That's because I get 180 degrees in the triangle, and if I put one right angle in there, it makes sense that those other two have to add up to 90. I also have something called a hypotenuse. The hypotenuse is the side that is not only opposite the 90-degree angle here, but it is also the longest side of the right triangle. There's a relationship in geometry that says in a triangle the longest side is always opposite the largest angle. And since the 90-degree angle has to be the largest, the hypotenuse must be the largest side, or the longest side. The other two sides are called the legs. And the legs have a relationship to the two acute angles, depending on which angle of reference you're using. So if I'm sitting here at angle A, and I'm in this corner, then the side opposite angle A is going to be the side that I would hit if I kind of bisected the angle and ran into the other wall. The side adjacent to angle A is the side that helps to form angle A. So from A as my reference point, I would call this side, I'll put in a C here, BC, the opposite leg, and I would call AC the adjacent leg. Now, of course, if I was here in angle B, then this would be the opposite and this would be the adjacent. The only piece that never changes is the hypotenuse. Hypotenuse is always opposite the right angle. Okay. So looking at this right angle, and again, using angle A here as my point of reference, I can set up ratios of the sides of the right triangle. And it all has to do with similar triangles and, the fact that corresponding parts are in proportion, etc., etc. So what I can tell you is that the three relationships involved two out of the three sides of comparison. The first relationship is the sine function. The sine function, S-I-N-E, is abbreviated with the first three letters of the function. The sine function, pronounced sine, even though it's S-I-N, the sine of angle A is going to be equal to the opposite leg as compared to the hypotenuse. I have another function called the cosine function, and the cosine function also is abbreviated by the first three letters of its function name. And the relationship there is that the cosine of the angle is actually equal to the adjacent leg as compared or in ratio with the hypotenuse. And then the third and final from right triangle trig that you learned was the tangent function. And the tangent function, again, abbreviated by the first three letters of its function name, is actually the relationship of the opposite leg as compared to the adjacent leg. Whoops. Now, there's a whole bunch of ways that people remember this. SOHCAHTOA, some old hen caught a hen, taking oats away. Oscar has a heap of apples. It really doesn't remember how, or it doesn't matter how you remember it, but you need to know these relationships. You need to know that the sine ratio compares the opposite to the hypotenuse, that the cosine ratio compares the adjacent to the hypotenuse, and that the tangent ratio compares the opposite to the adjacent. Okay? And again, what I can do is say, some old hen caught a hen or horse taking oats away. And this is where the SOHCAHTOA comes in. Not really fond of SOHCAHTOA because a lot of people misspell it, and that's no good. But it's basically using the first letters of each of these words. Sine, opposite, hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. If you have a good handle on these relationships, then you don't have to worry about this. But this is one of the things that it is expected that you come into this class knowing. You're supposed to be at a mastery level at this particular piece, knowing how to find an angle given the ratio, and knowing how to find the ratio given an angle. We'll do a few of them in class, but other than that, this is the notes for this. The other very important relationship in a right triangle has nothing to do with the angles at all. It has to do with the sides. It's called the Pythagorean theorem. The Pythagorean theorem, before I talk about that, just realize that whenever you label the vertices of a triangle, they're always labeled in capital letters. And then the sides opposite are labeled in the lowercase letters. So if this here is angle A, then the side opposite angle A here is going to be little a, side little a. And if this is angle B, then the side opposite angle B is little b, and the right angle, C, is going to be opposite little c. And then the Pythagorean theorem says, if you know you have a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse, or a squared plus b squared will always equal c squared. There's a lot of proofs for this particular theorem. Hopefully at some point in your careers you've seen one of these proofs. But most of you just know this theorem, so you have to know how to use it. Keep in mind that it doesn't matter how the triangle is labeled, C represents the hypotenuse, always. So what we want to do now is get some basic vocabulary into our notebooks so that we can start to memorize these words and understand what it is that I'm talking about when I start talking about terminal side and angle of rotation. If I take a basic circle and superimpose it onto a coordinate axis, xy plane, then I have the beginning of what becomes the unit circle. What I want you to understand is that in this coordinate axis, in this circular plane, I have quadrant 1 sitting up here in the upper right corner. Quadrant 2 sits over here in the upper left corner. Quadrant 3, and then quadrant 4. And again, understand that those are always labeled by Roman numerals. We also have down here, over here on this side, the x-axis is called 0 degrees. Up here, moving counterclockwise around that circle, this would be 90 degrees rather. This would be 180 degrees over here on the left of the x. Continuing around the circle, we have 270 degrees. And then that brings us all the way back to the beginning at 360 degrees, knowing that there's 360 degrees in a circle. Okay. So if I draw a ray from the origin to the endpoint of the circle where it intersects here, this is called the terminal or the initial side of my angle of rotation. And what I want to do, hopefully, is demonstrate what an angle of rotation looks like. So if I move this any number of degrees around my circle, I will end up with an angle of rotation in a positive direction or in a negative direction. So this is the first time you're going to actually see negative angles of rotation. That doesn't mean that the angle itself has a negative measure. It's the direction in which you're rotating. So again, oops, I need my pen back. This is called the initial side. All angles of rotation start there at 0 degrees. Every one of them starts at 0 degrees. So then if I give you a random angle of rotation of, say, 120 degrees, the tip of the arrow, not the ray tail is fixed at the origin, would rotate past 90 and into quadrant 2 to, say, 120 degrees. So this now is called my terminal side. The terminal side is where the angle of rotation stops or terminates. And I could write a little rotational arrow here to say 120 degrees. Okay, where it begins over here, it's called the initial side, always happens at 0. The terminal side is where that angle of rotation stops. And then that is the angle of rotation through which it happens. Okay. If the angle of rotation is positive, we always go counterclockwise. Okay, I've redrawn my circle. This time I've put a few extra degrees labeled on here just to make it a little bit easier on you. So I went around the circle and marked it every 30 degrees throughout each of the 4 quadrants. Notice I did not relabel 360 because we typically don't do that. 360 starts over at 0 again. Okay, so I've placed my initial side back on my circle, and I will rotate. And I will rotate it 210 degrees. And that's great. And again, the way that I would show that is to put in a tracing arrow just like that so that you can see the direction and the angle of rotation. Here's the interesting part. I'm going to go back to the initial side. So starting back here again, I'm going to give you another angle of rotation. And there you have it. Now, here's the problem. You didn't see me rotate. So you really don't know which direction I went in. Did I go from my initial side all the way around counterclockwise this way, 300 degrees? Or did I simply, from the initial side, go clockwise 60 degrees? Which would actually be negative 60 degrees. Those are what we call coterminal angles. Coterminal angles are angles of rotation that share a terminal side. That prefix co means to share. So coterminal angles share a terminal side. So just a couple other little ideas. First off, if I say to you, in what quadrant will an angle of rotation of 150 degrees terminate? You would rotate this 150 degrees and stop there in quadrant 2. If I said to you, in what quadrant will an angle of rotation
of negative 100 degrees terminate, you would come clockwise past 90 to about negative 100 there, and you would tell me it's quadrant 3. If I said to you, in what quadrant would an angle of rotation of 90 degrees terminate? 90 degrees actually puts you on the axis. That is not in a quadrant. The axes define the quadrants. So in that case, you would say it doesn't fall in a quadrant. 90 degrees is what we call a quadrantal angle. Okay, so let's just get those vocab words down, and then we'll call it quits for the day. So here's the words that you need to get into your notebook. Theta. Theta is actually the symbol that we use to represent all angles of rotation. It looks like a capital O, but it has this horizontal line through it. Some of you may have seen theta if you're taking physics, because theta is used a lot in science. Theta is the Greek letter, capital H actually, in the Greek alphabet. Not that that matters, but it is what we use to represent the angle of rotation. Coterminal angles we talked about. Coterminal angles share a terminal side. The quadrantal angles I just gave you, those actually form the quadrants. They're on the axes. And then the terminal side of an angle is where the rotation stops. So finish copying those in your notes, and then we'll see you tomorrow. Thanks. And again, sorry about my voice.